Hi everyone, welcome to Exponent Laws video. Exponent laws. These are the laws of working with exponents. And if you forget them, you can always teach yourself again by expanding things as multiplication and noticing the patterns, which is what we've been working on in class. When we are multiplying exponents with the same base, we have 10 to the 5 times 10 to the 2. Let's see what happens if I expand that out. Here's 10 to the 5. 10 times 10 times 10 times 10 times 10. Okay, that's 10 to the 5. I hope you agree. Times 10 to the 2. Now I'm mixing my multiplication signs, but I hope you understand. That's 10 times itself how many times? Well, we count them. 1, 2, 3, 4, 5, 6, 7 times. That's 10 to the 7. Okay? I could have also said that's 10 to the 5 plus 2. Okay, so let's make a rule. When multiplying exponents, when multiplying powers with the same base, add the exponents. There's our rule. Boop, 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 boop. There we go. Okay, now what if we had x to the 3 times x to the 2? I don't know what x is. But I do know that this will be x to the 2 plus 3, which is x to the 5. Done. Final answer. Because I need to know what x is. Suppose I say let x equal 7. Well, then x to the 5 would be equal to 7 to the 5. And I don't have my powers of 7 memorized that high. My goodness. Okay. So 10 to the 5 divided by 10 to the 3. What's happening here? Maybe I should use a different color. Okay, so 10 to the 5 divided by 10 to the 3. Well, let's write it out. If we're ever confused, write it out. 10 times 10 times 10 times 10 times 10 divided by 10 times 10 times 10. Okay, I seem to remember that Mr. Jennings loves canceling things. Oh my goodness, this is so delightful. So this is 10 times 10 on the top. So this is what we're left with. 10 times 10. 10 times 10. Divided by what? 1. Okay, it's divided by 1. Okay, this is 100. Okay, now what is that? It's 10 to the 2. But I could have also said that's equal to 10 to the 5 minus 3. Okay, when dividing, subtract the exponents. Okay, we always subtract the one on the bottom. We always add the one on the top. Okay, so that's why it's positive 5 minus 3 down there. Okay, now if I have x to the 7 over x to the 4, by the same logic, that's x to the 7 minus 4. That's equal to x to the 3. Okay. Now let me actually give you another example that might be a little harder. Let's say x to the 3 divided by x to the 5. Well, I just keep working it the way I've shown you. That's x to the 3 minus 5. If it's 3 degrees out and tomorrow's going to be 5 degrees colder, that's negative 2, x to the negative 2. Okay, cool. Now that leads us to the next thing. But before we go on, let's write a little rule here. When dividing powers with the same base, subtract the exponents. There we go. Okay, cool. Hey, cool. All right, so now you want some of this in your cheat sheet, so put some of this in your cheat sheet, people. Now, when raising powers to powers, we're going to get back to this guy, this negative exponent, and what to do with that. But we'll also recall that we've seen that in scientific notation, like 10 to the negative 3. If I have 3.0 times 10 to the negative 3, that's equal to 0.003. Okay, the decimal places move 3 times in the opposite direction because negative. Okay, because I can think of that as 3 over 10 times 10 times 10. That's why. Divide by that many times. Okay. Now, when raising powers to powers, let's see, what do we do? Mr. Jennings, what do we do? Well, let's write it out. Let's do this exponent first, okay? This is 3 squared times 3 squared times 3 squared. That's 3 squared times itself 3 times. That's equal to 3 times 3 times 3 times 3 times 3 times 3. We add the exponents now because we're multiplying. So this is equal to 3 to the 2 plus 2 plus 2. that's equal to 3 to the 6. But you'll notice 2 and 3 here, I could get 3 to the 6 like this. That's equal to 3 to the 2 times 3. Okay, so now let's write a rule. When raising powers to powers, multiply the exponents. Okay, move that over here so that my notes are so beautiful. No, they're not beautiful, but they get the point across, I hope. Okay, now, x to the 9 to the 3 is x to the 27, folks. Okay, why? How do I know? X to the 9 to the 3 equals x to the 9 times 3. Put that in brackets so it's clear that's the power, or the exponent, I'm sorry. And then that's x to the 27, because 9 times 3 is 27. 10 to the negative 5. Okay, well, that's equal to 1 over 10 to the 5. It just means that's how many times I want you to divide by 10. So put on the bottom, I'm dividing by 10 that many times. And you'll note that that's how your scientific notation works. Okay, that's what's meant by a negative exponent. Just throw the whole thing to the bottom. The sign changes. And then last one, 10 to the 0 or x to the 0. Okay, anything to the 0 is 1. Anything to the 0 is 1. Those are your exponent laws, everyone. Okay, why? Why, Mr. Jennings? Let's say I have 10 to the 4 divided by 10 to the 4. Well, that's equal to 10 times 10 times 10 times 10 over 10 times 10 times 10. Anyone see that if I cut a pizza into 10,000 slices and then I eat 10,000 slices, that I've eaten one whole pizza? Just like tiny, tiny sliver slices. Okay? The whole bottom cancels, the whole top cancels, and when I cancel, I get 1. Okay, this all cancels away to 1, that all cancels away to 1. I could have also written this as 10 to the 4 minus 4. 4 minus 4, you'll recall, if I have 4 apples and Billy takes all of my apples, I have no apples left. 0. Okay, so that's why. This is the why. So if you remember the why, you don't need to memorize the how. So I hope that I've convinced you of the value of understanding why all this stuff happens. Bye for now, everybody.